This is continuing looking at overriding. D1 is less than D2. Okay. I tried to wing it last class, and it didn't go very well. So I wanted to show you an actual example of it. This is out of the book. We got a class named distance. Down here, we create a new instance distance, D1 and also D2. Remember, to create an instance, you have the class name here, then whatever user-defined named here, whatever you want to call it, equals new distance, and then we got this, which we'll talk about. For this distance, we have the meter, and you see by default here we have a get and set defined. And then we got these, which we'll talk about here in a second. So this isn't doing anything too exciting. It's sitting there hard coding in the value of meter. And that occurs, that does your set for you. That's setting it equal to a value. Now we got public static bool operator. This is going to return true or false. That's what the Boolean does. The operator, that's a reserved word, just should be operator. And here we're checking a less than. And the less than I'm redefining is these ones down here. But specifically, after that, we're putting the distance here following it. And then you're checking if the meter in D1 is less than the meter in D2. If that'll return true or false, then that returns it, and then returns the value for the operator itself. I don't know if I could come up with one here, but we'll try. Let's say points. Or maybe point. Except for that might be a reserve word, but we'll go with it, see if it lets us. Got point here, point here. And I'm going to have x1 and x2. I don't know if it'll let us put both of these in one, but we'll see. I guess it will. Now, these are like two values on our number line. And we're going to be calculating the distance between them. Basically means just subtract them. So 5 minus 3 is 2. 15 minus 7 will be 8. And we want to check which one has a less than, greater than in terms of that distance between the x values. So I'll call these point. Same down here. Okay, and I'm going to have a variable in here that's a double. I'll call it temp. Although I could probably put this in a separate method. Let's see. Private double calculate distance. And don't think I actually need to pass anything. We'll see. And then I'll have double temp here is going to equal temp is equal to math dot absolute value of x1 minus x2. And then I'm going to return temp. So this is going to subtract the two values. And so I don't have to worry about which one's larger, which one's smaller. For example, if I subtracted 2 minus 3, that'd give me a negative 1. Take the absolute value of it, and the absolute distance between them is 1. So I'll return that. So I can get rid of this. And I guess I need to call that. So calculate distance of D1. Calculate distance of D2. And down here, do the same thing. Now, given these points right here, first I'm going to check to see if it works, and I'll go back and talk about it. My D2, that distance there is 8. That should be greater than this distance, which is 2. So I should get that this first one. D1 is less than D2. But let's run it and see. D1 is less than D2. So what I've done is I've declared an object, a class called point. I got two variables I'm working with, two fields, attributes, however you want to refer to them. They both have put a get and set on both of them. I made this private, so it can only be called from within this class. For example, I can't come down here, and hopefully you can't, D1 and there's no calculate. Because I don't want the user, in this case the programmer, to call that directly. That's only going to be a method that's used within my object. And so then down here, I redefine the less than, I redefine the greater than. And again, what I have after this is what's going to go before the symbol, what goes after the symbol. And then this D1 calculate distance. This is very specific to my first point. Though my point, I guess, has two x values. Guess a better than point would have been distance, but oh well. Does that make sense on what that's doing?
Yeah.
Okay. Really, I was drawing a blank on an example. I suppose you could have like the distance formula where you got two sets of points, and then here you're checking the distance between these two set of points and these two set of points, and seeing which one's greater than, which one's less than. That's bad. Usually I can think of a math example besides just numbers. The one they did in the book is just based upon numbers, which is fine, but you don't really see the power of it because you could just simply do an less than and greater than directly on numbers. But you can have entire calculations here based upon this less than or greater than. Yeah, I can't come up with any ideas on that. But anyway, that's redefining it. Now you're not limited to the less than and greater than. I wonder if you can redefine a dot. I'm just curious. My first guess would be no, but we'll see. So refine a dot there. Overloadable binary operator. Okay, so it's not anyone. It has to be a binary operator. So guessing equals equals. Oh, okay. So I got that. Then redefine not equal. So you can do those. These are all ones like you can put in an if statement. In an if statement, you can't put something like if sales dot profit. So they're saying it has to be a valid binary operator here. You can't do equals either because equals is an assignment operator. It's not a binary operator. There's less than or equal to. Let's do that. Let's see if it allows that. It's a valid binary operator, so it should. But you probably have to have a greater than or equal to based upon that past feedback. Maybe. Yeah, greater than or equal to needs to be defined. So they got to get in pairs for some of these. Maybe all of them. Like that. I thought the exclamation was a binary operator too. Let's see. Except for it shouldn't have a pair. No, doesn't like that one. Binary operators. But anyway, that shows you redefining those. Like I say, you look at this and you say, well, why go to all that bother? Because all we had up here was one number anyway. We only had that one integer value. Probably because the author couldn't think of a valid example like I was drawing a blank upon. But really, it's anything that you define. If you're net worth might be something you could define. Not that I can define net worth. But maybe if you had assets in here, liabilities. I'm not a business major, so keep that in mind. Probably don't need a separate method for declaring that. There we go. Double D1. It's not double. Net worth. And just muted myself. So let me unmute myself. Or I muted you. Now see what button I'm hitting up there. Net worth. And maybe I'll create one. Private double net, and I'll pass in nothing, and this will return your assets minus your liabilities. Let me think. If I assets, let's say I own $10,000 or $10,000 worth of whatever, and I owe $9,000. I think that's probably a simple calculation for net worth. Okay, so then down here, I'll be comparing net to net. That'll be net worth. Net worth. Net. And net. There's a lot more to your net worth than just that simple calculation. So instead of there being like one operation here, you can almost envision it being like 50 statements being done, and all that to calculate your net worth. So then down here, we're not necessarily worrying about all that calculation. D1 and D2 here, you see matches the D1 and D2 here. Let me change this to Frank and David. We do an underscore net worth, underscore net worth. And then over here, assets equals to 5,000. Liabilities equals to 3,000. And here it'd be assets equals 10,000. Liabilities equals 2,000. So these are creating instances of my objects, of my classes, and it's setting these values at that creation. So then down here, I check to see if Frank's net worth is less than David's net worth. If so, then Frank is less than David. Else, if David's net worth is less than Frank's net worth, then David is less than Frank. Now the difference, Frank is 5,000 minus 3,000, that's 2,000. David is 10,000 minus 2,000, which should give us 8,000. Now notice when I calculate somebody's new net worth, I don't have to worry about the actual calculation. I just need to pass in what parameters are, and then it calculates that for me. Frank is less than David, which matches what we're looking at. Maybe a good example of this type of concept. See if I can find it. It's a 1040. It's a tax document. A lot of people pay to have somebody do their taxes. It's curious. I won't do more on that first page, but I think there should be more there. Maybe not. You come down here, and you got your adjusted gross income. Okay, we start here with our okay, starting at line 11. you got your tax from the form. You add any amount from Schedule 2. Then you subtract child tax credit. You add other taxes in, and that's from this Schedule 4. And okay, then you add your two taxes together here, your federal income tax withheld and refundable credits. And then down here, you're checking. If line 18 is more than line 15, subtract line 15 from line 18, the amount you overpaid. Amount you owe, subtract line 18 from line 15. So these are just kind of reversed. This is where you could override the less than and greater than, and you could use objects to set all this up. And there's a lot of information that goes in here. This doesn't seem like too bad, but then when you, like if you're looking at other taxes, attached Schedule 4, you come over here, Schedule 4, other taxes. You see here we got a bunch of different calculations that need to be done. Now you put each one of these in their own separate little bit of code, and it makes it easier to maintain, in theory. Because if any of those schedules are shared among other forms, then you can reuse that code. And if you change it in one place, then it propagates through all the places. This is one method people that write like the TurboTax program, they could use that. Now, whether they would actually overload an operator or not is questionable. But definitely they could use the whole concept of object-oriented programming or class to define some of these. Anyway, probably more than you wanted to hear about the overload an operator. This talks about what I discovered because it told me. Always overload opposite operator of the comparison operator. For example, whenever we overload less than operator, we have to overload the greater than operator also. Same applies to the equals equals not equals operator. Remember the dynamic polymorphism. That's where in programming, it's all about changing behavior, while dynamic means changing the behavior of an object at runtime by overriding the definition of a method. It's also known as late binding. In C#, method is overridden by two ways, virtual method and abstract method. Virtual is a keyword used with the method in base class to define a virtual method. Virtual method has a definition of its method. Its derived class can inherit or override its definition. Thus, when calling a method name, the runtime will determine which method to invoke. And see, this is our syntax here. So down here in our class vehicle, we got public virtual void run. Then console write line there. Under class bike, we have public override void run, and we have a console write line there. And see, we got vehicle VC equals new bike. Now bike, you see here is inheriting from vehicle. So it's bringing it because a bike is a type of vehicle. Now, run is declared here, but it's also declared over here. So when you choose this vc.run here, the question is, well, which one does it run? See, this is what overrides the virtual method here. When you do the run here, that's why when you do the run here, that's why it does this bike run. So. If, and this is a part right here, if you do not see this run here, it's not underneath my bike, that's when it'll revert back up there to that virtual and to find out, run that one. I'm trying to think about where would be a good example. I mean, they did a very simplistic example, but I'm not really coming up with a good example of where would you implement that at, or why would you need to. Grab a drink here. Now we got an abstract method. Abstract is a keyword used with the method in abstract class to declare an abstract method. Unlike virtual method, abstract method doesn't have its definition of method. Thus, its derived class must implement the definition of an abstract method, otherwise compile time errors will generate. Abstract methods always declare inside an abstract class. Okay, that's our syntax. Now here, we got our abstract class vehicle. And within that, we've declared this method. It's abstract, void, run, so nothing's going to be returned, but no definitions here. This is, if you ever programmed in C, it's kind of like a prototype. We're just kind of declaring what it's going to look like. Then down here, it's actually defined in the bike part. And that's where we do this console write line. Down here, it's creating a new bike. And again, the bike is inherited from the vehicle, which is up here. And so then when you do your vc.run, it'll run that code. I almost think of this, whenever I've written this in the past, I almost think of it as this defines what all the runs are going to look like. And then in each particular type of vehicle, you can have a different code for the run, but all has to follow this format. When I say all follows that format, it means they're all void, nothing gets returned, nothing gets passed. And all it does is just do a simple write line in this bit of code. I know that's still not a good example. In a game, maybe your run feature. If you had a Star Wars game, and I can think of examples probably already that don't follow this, but in a run game, or a run method in the game, your character moves left or right, but maybe you want a character to jump as it's going right or left. It's still being maybe past the same parameters, but you're not actually going to do the same code within there. So this kind of just defines a generic way everything's going to be used. Again, not a great example, but some of these it's hard to come up with great examples of where you see this. And you can see they took a cop out. They just did console write lines, which isn't bad. Shows you what code you're in. Now here's a develop a transformer. We all watched the Transformers film. They're intelligent vehicles with which can transform into jets, cars, and boats. Your job is to make an application where transformer can change its behavior into the following vehicles. Your job is to implement a run method for each vehicle that transformer runs whenever the landscape changes. I don't really want you to follow this per se. I want you to define, and you doesn't have to be a transformer. If you want to come up with your own example, that's fantastic. But come up with an object-oriented class that has fields, attributes, variables within it. Your test code should create an instance of it, and it should be some kind of method performed. Example. You don't have to overload operators. Nothing that bizarre. Let me define dogs. Public string breed. So breed name. Public int age. You don't have to create a bunch of gets and sets for these either. I just want to keep it simple for these objects. I mean, if you wanted to go and do that, you're welcome to. Public running speed. Yeah, I guess I ought to say it's a double. And public void dog string breed name b-name int age. No, I don't want age. B age, breed age, breed running speed. Member names cannot be the same as their enclosing type. B name. B age is equal to age or age. And I'm obviously forgetting something. There it is. Shouldn't be void. I'm trying to create a constructor. This is going to create an instance of it. For example, down here in my code then, one of my dogs' name is Misty. And she's a Australian Shepherd. She's 3 years old now. Speed, I have no clue. Say 5.2. Misty. Oh, that's horrible. Mia. Misty was her old dog. And the other dog's name is Josie. She's also an Australian Shepherd. She's I think 1 year old, and she can probably run faster. I don't even know if these are even accurate speeds. Let's say 6.1. So those are going to create instances of those by calling this constructor. So this is my constructor. Now I want to at least have one method. And maybe my method is going to be that they're going to speak. Public void speak. Maybe it'll also appear. Maybe I'll actually have their full name. Public string full name. Well, first name. And down here, string B first name. And I'm going to set my first name equals to B first name. And I'm going to pass in Mia. And I'm going to pass in Josie. Now the speak, probably I want to pass in a parameter here. Now so this is be the speech that they want to give. So down here I'll do my console dot write line. I'm going to be passing in a parameter here. This will be their name. So Mia says, and then I'll put another parameter here. Now I do a comma here, F name, comma, and then I'll be referring to their speech. So then down here, I'll say Mia speak. Hello, everybody. Josie speaks. Actually, I guess I could say they came up to each other. And Mia says, hello, Josie. Josie says, hello, Mia. So nothing too exciting on that. Let's run that. Show you what it looks like. Mia says, hello, Josie. Josie says, hello, Mia. Now, if you want to use the transformer concept, you can. That's up to you. If you want to come up with your own, because you can create an object based on pretty much anything. Cars, you could do a car, and within the car you have your model. The manufacturer. I was trying to think of the name of it. Like Honda Accord. I'm trying to think what that Honda is. The manufacturer. Age. So it's a 2000. You could have the value. So anything. But I want you to create an object. Again, you should have at least 3 fields, at least 3 attributes, variables. You should have a constructor where you create an instance of it. And you should have at least one method. And then within that, you should have your test program that uses those. that make any sense what I'm looking for in that project?
Makes perfect sense to me.
Okay. I'm going to stop the recording and I'm going to start it again just because I'm worried about it.